Okay, I'm going to discuss exponential equations. There are two cases of exponential equations. Convertible to a common base. If so, you convert to a common base and you solve. Okay? Otherwise, you could use the natural logarithm. All right? If it's natural log of e to something, if you just have the power. Reason? Because natural log is actually log base e. Log base e of e to a power just leaves you the power. If you have natural log of something else to a power, you can move that power to the front. Okay? Reason being, natural log of b of the p power, assuming that b is not e, is log base e of something else to a power. You can move the power to the front. Okay? So here goes. Example 1 is both of these are powers of 2, can be written as powers of 2. Okay? 2 to the 3x plus 13th. 128 is 2 to the 7th. Now, if this equals this and the base equals the base, then the exponent equals the exponent. Okay? Subtract. And then from here it becomes a simple equation. 3x equals negative 6. Divide by 3, divide by 3, x is negative 2. Now, let's say I don't recognize that these are both writable as powers of 2. Well, then I could use the natural log. Natural log of 2 to 3x plus 13th equals the natural log of 128. That's log base e of something other, of a base other than e. So we can take this, using this rule, we could take this 3x plus 13 in parentheses to the front. Okay? I'm going to do that again. Okay? I'm going to take, let me actually go ahead and explain it that way. Okay? So I'm going to take this again. I'm going to pretend that I do not recognize that 2 and 128 are powers of a common number. All right, so I'm going to go ahead and take the natural log of both sides. Okay, natural log of 2 to the 3x plus 13 equals the natural log of 128. Okay? That's natural log, or log base e. The base is not e, so we're going to take this 3x plus 13 to the front in parentheses, and that just leaves me the natural log of 2. Okay, now resist the temptation to distribute this and just divide it off. All right, so what I'm going to do is I'm going to grab a calculator. All right, and just to be on the safe side, I'm going to make sure that this comes out as a non-repeating decimal. Because if it comes out as a non-repeating decimal or a non-terminating decimal, it's irrational. However, if it comes out a whole number or terminating decimal or repeating decimal, it could be written as a fraction. So, natural log of 128, 4.852 something, divided by a natural log of 2, 7. Okay? Subtract my 13, and 3x is negative 6. Divide by 3, divide by 3, x is negative 2. Okay? Both methods gave me the same answer, it's just this one took longer. Now, on this one, these are both powers of 3. So I'm going to rewrite this as 9. Sorry, I'm going to rewrite this. 9 and 27 are both powers of 3, so I'm going to rewrite this as 3 squared. Put the original exponent in parentheses. 27 is 3 cubed. Put the original exponent in parentheses. Okay? Again, if this equals this and the base equals the base, the exponent has to equal the exponent. I'll go ahead and do the distributive property. 2x plus 2 equals 3x minus 12. Okay, I got x's on both sides. I don't like that. I'll subtract the 3x that's on the right side. So I have negative x plus 2 equals negative 12. Okay, subtract the 2, subtract the 2, negative x is negative 14. And if negative x equals negative 14, positive x equals positive 14. Okay, I've erased example 2 and replaced with example 3. I left example 1 up for comparison purposes. Now, with example 1, we could have done this without a logarithm or with a logarithm. Okay? Here, we don't have a choice. Here we did, because here, these two were both sides were convertible to a common base. Here, you can't do that conversion. We have to use logarithms because 5 and 26 are not powers of a common number. Because these are not convertible to a common number, we have to use a logarithm. All right, so we're going to do the natural log of both sides. Now, because this is log base e of something else to a power, we can take the power of the front. I'm going to put it in parentheses. All right, now just like I did here, I'm going to divide off the natural log that's on the left side. So I end up with 4x minus 1 equals, now I'm going to make sure that I don't get a decimal, I don't get an integer, a repeating decimal, or a terminating decimal, okay? So natural log of 26 divided by a natural log of 5, that is a non-repeating, non-terminating decimal. Okay, the calculator rounds off the last digit. Okay, so this is what's called irrational, so we'll just leave it the way it is. Okay, we want to get the x by its lonesome, so we'll add 1 like we normally would. So now I have 4x equals the natural log of 26 over the natural log of 5 plus 1. Next, I would divide off the 4. Natural log of 26, I'm going to raise this up a little bit. Natural log of 26 over the natural log of 5 plus 1 over 4. Okay, so x equals the natural log of 26 over the natural log of 5 plus 1 over 4. That is an exact way of writing this solution. Here's another exact way. X equals the natural log of 26 over the natural log of 5 plus 1 in parentheses divided by 4. This is also exact, and it leads to an approximate solution. Okay, x is approximately equal to, so parenthesis, parenthesis natural log of 26, balance the parenthesis if you have to. Actually, we could just do these one at a time. Natural log of 26 divided by a natural log of 5. And then with that number, hit enter or equal, and then add 1. You should be looking at 3.024369 blah, blah, blah. Now divide by 4. and I get approximately x is 0.756. This is approximate. Okay, so two ways to write the exact solution, but this is approximate. Approximately equal to. Okay, and that's a decimal point. All right, I'm going to pause here and set the next three examples. Okay, so here are three more examples. All right, so this one. Remember that E is approximately 2.7, 1828, 1828, 459. Okay? There's no way to convert E and 14 to a common power. So, we have to use a logarithm. So natural log of e to the 0.15x equals a natural log of 14. All right? Now, it's log base e of e to a power. So that just allows me to take the 0.15x out of the exponent. It cancels the exponentiation. All right? Why? Because log base e of e to the 0.15x is just 0.15x. All right, that's why. All right, so I'm going to do that again. E and 14 are not convertible to a common base. So we're going to use the natural log. Now, log base e of e to a power just leaves you the power. Okay? So the only thing I have to do now is divide off that 0.15. So x equals, and now it's calculator time. Okay, looks like I'm going to have to round it. So, natural log of 14, hit enter or equal. I'm looking at 0.2639 something. Then divide by 0.15, and I get approximately. You can see that, and that would round up to 17.6. Okay, because it says round to 1 decimal place. This one, round to 3 decimal places. All right, well, no problem. The first thing I have to do, however, is isolate the base and exponent. So I'll divide off that 12. And e to the 0.05t is 6. All right, so we'll take the natural log. Both sides. Log base e to e of a power just leaves you the power. Okay? Divide that off. Divide off the 0.05. And t is approximately. All right, natural log of 6, hit enter or equal. 1.7917594, blah, blah, blah. Divide by 0.05. Round to 3 decimal places, that is 35. You can see what I'm looking at on my calculator. Round to 3 decimal places, that is 35.835. Okay, this next one. This time I want an exact solution and an approximate solution around to 3 decimal places. So do natural log of e to the 2x plus first equals the natural log of 15. Now, because this is log base e of e to a power, it just gives me the power. Like so. I'll go ahead and subtract the 1, and we have 2x equals the natural log of 15 minus 1. Do not combine that into the natural log of 14. That's irrational. That is rational. They do not combine. Okay? Think of this as a pair. They stay together, they don't include that. Divide off the 2. So x equals the natural log of 15 minus 1 over 2. Or natural log of 15 minus 1 divided by 2. All right. So this is an exact solution. This could also be called irrational form. That's another way of describing the form of that solution. Okay? Now here's an exact, or an approximate. All right? Parentheses. Okay? Natural log of 15. Hit enter or equal. 2.708 something, subtract 1. 1.708 something, divide by 2. Okay? Approximate. X is approximately 0.854. Okay, before I go on to the more advanced problem of example 7, I'd like to review example 3 again. That way we can compare what we did in example 3 with what we're going to do over here. So 5 and 26 are not convertible to a common base, so I did the natural log of both sides. That allowed me to take the exponent to the front. All right, and then I didn't distribute. What I did instead is I divided off the natural logarithm that was on the left. Okay, so we have 4x minus 1 equals the natural log of 26 over the natural log of 5. Okay, add your 1, and we had 4x equals the natural log of 26 over the natural log of 5 plus 1. Okay, and then we divided off the 4. So x equal natural log of 26 over the natural log of 5 plus 1 over 4. Okay, and that's an exact solution. Now, over here, we're going to have to do something similar. Okay, I'm going to bump it over a little bit. 5 to 2x plus first equals 6 to the x minus second. Again, obviously, these two are not convertible to a common base, so we're going to use a natural log. Okay, well, since this is a base other than e, as well, and ditto this one, we're going to take the exponents to the front just like we did before. Okay, so that's going to be 2x plus 1, natural log of 5, equals x minus 2 natural log of 6. And just like we did here, we're going to divide off the natural logs on the left. Why the left? Why not, okay? It's consistent with what we would normally do if there was only one of them. So that's what we'll do here. So those two cancel, and we're left with 2x plus 1 equals, well, we got x's on both sides. It makes sense that I want to get this out of the parentheses. So I will go ahead and distribute. This times this and this times this. So x natural log of 6 over natural log of 5. Okay, I'll clean that up so it's more legible. X natural log of 6 over the natural log of 5 minus 2 natural log of 6 over the natural log of 5. Okay? I want to get the x's to the left. So I will need to subtract x natural log of 6 over the natural log of 5. I'm going to do the same thing here. I'm going to do the same thing here. So I end up with, I'm going to rearrange the terms so that the x's are together. So 2x minus x natural log of 6 natural log of 5 plus 1 over the natural log of 5 and then plus 1 equals 2 natural log of 6 over the natural log of 5. Don't forget the minus. I almost did. All I did here was rearrange the terms. Okay? I now want to isolate the x's, so I will subtract the 1. I'll go ahead and put it in the front as well. So now what I have is 2x minus x natural log of 6 natural log of 5 over the natural log of 5 equals negative 1 minus 2 natural log of 6 natural log of 5. Okay, I'm going to copy this over here as is. Okay, so 2x minus x natural log of 6 natural log of 5 equals negative 1 minus, now make sure everything fits, 2 natural log of 6 over the natural log of 5. Okay, all I did was copy what's here, here. Now, I want to get one x out of everything. So I'll go ahead and factor an x out of this. So that would leave me 2 minus natural log of 6 over the natural log of 5 equals negative 1 minus 2 natural log of 6 over the natural log of 5. And then all I need to do now is, this is x times this binomial, I'll just divide it off. So x equals negative 1 minus 2 natural log of 6 over the natural log of 5 over 2 minus the natural log of 6 over the natural log of 5. And as far as I'm concerned, that's good enough. I've checked this in at least one online homework format, and it's worked. Okay? If your instructor, regular instructor, teaches you further simplification steps, you would probably need to do those, if your regular instructor does. However, for me, that is good enough. Okay, I plan to solve this equation. Solve 13 times 9 to the 7x power is 78. So my first order of business is I want to isolate the exponential component. So I'll divide off the 13. So I want to isolate the exponential components, so I divide off the 13. And I get 9 to the 7x power is 6. Try to write it a little bit more legibly. Okay. Now 9 and 6 are not convertible to a common base. So I'll use the natural log of both sides. Now, because this is log base e of something other than e to a power, I will take that 7x to the front. Okay. Now, consistent with how I've done these other problems, I'm going to divide the natural log off the left side. Okay? As I said, I'm going to divide the log off the left side. And that leaves me 7x equals natural log of 6 over the natural log of 9. My final step is to divide off the 7. I'm going to show it with an arithmetic division symbol. So x equals natural log of 6 over the natural log of 9 divided by 7. It says round to 4 decimal places, so that's what I'm going to do. Okay, what I have to do is the natural log of 6, then divide by 9, and then divide natural log of 9, and then divide by 7. So that's exactly what I'm going to do. I'll do them one at a time. So natural log of 6 equals divide by a natural log of 9. And now divide by 7. Okay, round to 4 decimal places. X is approximately 0.1165. I'm going to solve this equation. So my first order of business is to isolate the exponential component. So I'll need to divide off the 55. Divide off that 55 like I said I would. And I have 7 to the x plus 9th power equals 2/11 because these are both divisible by 5. Okay, 7 and 2/11 are not convertible to a common base, so I'll use the natural log. And this 2/11 will remain in the fraction bar in fraction in parentheses as a fraction in parentheses for the rest of the problem. Now this is log base e of e to a base other than e. So the x plus 9 will go to the front, and I'll have the natural log of 7 equals the natural log of 2/11. Consistent with how I've done other problems, I will divide off the log that is on the left side. So, all I have is just x plus 9 equals the natural log of 2/11. Okay, I'm going to make that look more like a fraction. All right, and then I need to subtract the 9. So x equals natural log of 2/11 over the natural log of 7 minus 9. And I'm going to round this to 3 decimal places. So x is approximately, I'll do this, then I'll divide by this, and then I will subtract 9. So, natural log 2/11. So I'll just do 2 divided by 11. Okay, and that's division by. You can hopefully see. I'll hit enter or equal. And that's done. Now we'll divide by the natural log of 7. Enter or equal. Okay. And then I will subtract the 9. And I get approximately negative 9.876. What I intend to do here is some exercises with exponential models, some examples with exponential models. So the fictitious town of Zwitzville, okay? I don't know whether a real town of that nature exists or not, but it's a fictitious town made up for this problem. So if there's a Zwitzville somewhere, pretend it's in another state or another country, okay? So Zwitzville had about 1,400 people in the year 2010. It has been growing at about 3.6% annually. A, create a model for the population. B, predict the model in 2035, round the nearest 100. Okay? So, before we do, so here's the idea, okay? Exponential models are based on the assumption of a percent growth or percent increase, okay? So, amount equals original value equals original times 1 plus or minus r to the power, okay? Where this is percent change as decimal. Okay? So since we're doing population, we could either do capital P or capital P of T. I propose capital P of T. So the original amount is 1,400. We're going to base this off the number of years since 2010. Years since 2010. Okay, so 1,400 times 1 plus, the reason it's plus is because it's growing at 3.6% annually. To the Tth power. Okay, so P of T equals 1,400 times 1.036 to the Tth power. Okay. B, 2035 equals 25, so T would be 25. Okay, the year 2035 says T is 25. Why? Because this is 25 years after 2010. All right, so P of 25 equals 1400 times 1.036 to the 25th power. Now most calculators, you could just enter this in exactly as is. 1400 times parenthesis 1.036, your generic exponent button, 25. This was what it would look like on the calculator that I'm using. Okay? So, this is approximately 3389.4. Okay? But to the nearest person, that because it's population, okay, we normally round this to the nearest whole person. 3390 people. But to the nearest 100, as population, we normally round the nearest whole person. But the directions say to round to the nearest 100. So if we're rounding the nearest 100, that is 3,400 people. The nearest 100, 3,400 people. Okay, now I've added another question about when would the population reach 4,500 people or 4,500 people. Okay, so this is the population model. That we did that in part A. If you need to see it again, rewind. Okay, we want to know when population is going to be 4,500. Okay, my unknown is on the right, so I'm going to switch the sides and divide, because I prefer my unknowns on the left. So 1,400 times 1.036 to the 10th power is 4,500. I'm going to divide off that 1,400, and we have 1.036 to the 10th power equals 45/14. Now, I need to get this t out of the exponent. So I'm going to use the natural log, because that's a base other than e. Since that's a base other than e, I'll use the natural log. All right? And since this is log base e of something other than e, I'll say it again. Since this is log base e of something other than e, the t will go to the front. All right? And I will be dividing this off. Okay, you'll be dividing that off, and t equals the natural log, make sure this stays in parentheses, 45/14 divided by the natural log of 1.036. Okay, now when doing this with your calculators, you will type in the natural log. Well, okay. Natural log of parentheses, make sure you balance these with parentheses, 45 divided by 14, balance the parentheses like so. Hit enter or equal. I'm looking at 1.1676 blah blah blah. Now, with that number still on your calculator, divide by a natural log of 1.036. And I get approximately 33 years. Very close to it. Okay? So t is approximately 33 years. Adding that to the year 2010, the year would be 2043. Okay. Okay, here I'm going to discuss a other type of interest, okay? Compound interest. Compound interest has two subtypes, continuous and periodic. Now, some courses include periodic only, okay? College algebra classes, business math class, advanced business math classes, applied calculus classes, which is also usually business calculus, usually include both of them as well. I think it's easier to start with continuous, so that's what I'm going to do first. Okay? So, but I will at least give people an idea of what this looks like for later. Okay? So, accumulated value equals the principal, and then this is where things change, become different between the two of them. E is a constant. It's 2.71. It's approximately 2.7, 1828, 1828, 459, and then it goes all over the place forever. Okay? You'll hit shift or second. You'll hit shift or second ln on your calculator to get to that feature. Okay? For periodic, it's 1 plus the raised to decimal, and this is still time. This is what causes the most confusion because it's usually never given as a number. Okay? It's a number of compoundings per year. Now, if it says it's compounded monthly, there's 12 months in a year, so it would be 12. If it's compounded annually, there's only 1 year per year, so n would be 1. If it's compounded quarterly, there's 4 quarters in a year, so n would be 4. And semi-annually, that's every half year, so that's twice a year. Okay? So, Purple Grove offers 4.45% interest compounded continuously. If 1,040 is deposited now, find balance in 9 years. So do. It says it's compounded continuously, so the appropriate formula is the continuous compounding formula. Okay? Now, before I start plugging things in, I try to identify what the variables are, what the variable values are, because sometimes it's not as simple as it seems. So 1,040 is what we're starting with. That's our principal. We're looking for what the balance is going to be, accumulated value in 9 years. Rate, either move the decimal point over 2 places or just divide that by 100, is 0.0445, and t is 9 years. So A equals 1,040 times e to the 0.400, e to the 0.0445 times 9th power. Okay? Every calculator handles this differently. So what I would recommend you do is multiply this out. Okay? So leave the e, 0.0445 times 9 is 0.4005. Okay. Now, on my calculator, which is a Casio, you will typically see an LN button. On my calculator, it's right there. Some calculators, it may look like a capital I, but it's actually LN. Okay? Right above that LN, you will see e to a power. Okay? Now, I can't get this thing to focus. Okay? But above, you should be able to find e to a power if you hit shift or second. So, for me, I would just type in 1,040 times shift or second, depending on what your calculator says, ln. So again, 1,040 times shift or second ln. Okay? This is what it looks like on the calculator that I'm using. Okay? And in the nearest set, that's 2 decimal places, 1552, sorry, 0.27. Okay? Now for this one, it's still continuous. A equals PE to to the r-teeth power, where a equals, p equals, r equals, t equals. Well, rate is still what it was before. T is 9. Now that 1600 is what we're hoping to have in 9 years. That is an accumulated value. We don't know what we're depositing, what we're starting with. As I said, determine what your values are before you start plugging things in. So I want to know when 1600 will equal e to the p times e to the 0.0445 times 9th power. Okay, that's my unknown. That is what I'm solving for. So what I'm going to do is, since that's my unknown, I'm going to switch the side and move it over here. Okay, so I have p. I am going to go ahead and simplify the exponent. I'm going to pretend that I don't know what the answer to this is. So 0.4005 times 0.0445 times 9 gives me 0.4005 equals 1600. Now, my goal is to undo, I got p times this e to something. I'm going to do the multiplication by dividing. And yes, that is the arithmetic division symbol, and that's what I'm going to use. So p equals 1600 divided by e to the 0.4005 power. Okay, so I'll do similar to what I did here, except instead of timesing, I'm going to divide. So 1600 division, shifter second, ln, 0.4005. This is what it looks like on my calculator. Okay, if I can get it to show. Yeah, I'm sorry, the lighting isn't very good in here. Okay, not for this. I have to darken it because I want the board to be very visibly clear. Okay? Maybe this other calculator will be a little clearer. Yeah, that looks better. Okay, hit enter or equal. Okay, so the nearest cent, that's going to be $1,071.98. The problem also said it wants the nearest dollar. So the nearest dollar, that is $1,072. Unless given reason to do otherwise, unless given reason to do otherwise, assume nearest cent. Unless given reason to assume otherwise. Okay, this next part says, how long would it take for 1,040 to grow to $1,700? Well, it's still compounded continuously, so this is still the appropriate formula. Okay, so A equals, P equals, R equals, T equals. So the accumulated value is going to be 1,700, and we're starting with 1,040. The rate is 0.0445, and T is unknown. Okay, that's the question. So I want to know, when will 1,700 equal 1,040 times e to the 0.0445 teeth power. Okay, t is my unknown, so I'm going to go ahead and switch the sides so it's on my left. Okay, and then I'm going to go ahead and divide out that 1,040 and reduce. So e to the 0.0445 teeth power is 170. Actually, it can be reduced even more. Actually, I'll just truncate those zeros. And then these two are also divisible by 2. So 85. So 1700, 1040ths. That's 85/50 seconds. You don't actually have to reduce if you don't want to, because it'll come out the same in terms of, decimal form. All right? So that's base E, so I'm going to use a natural log. Like so. Okay? Since ln equals log base E, that allows me to take, that cancels raising e to a power and leaves me 0.0045t equals the natural log of 85/50 seconds. Okay, I'm going to diagonalize the fraction because I might be running low on space. Okay, so the next thing I'm going to do is divide off that 0.0445. Okay? I'll use a division symbol, the arithmetic division symbol. Okay, so T is approximately, so on my calculator, I'm going to type in the ln, 85, division or fraction bar, 52, balance the parentheses. Make sure that the parentheses are balanced. I go ahead and hit enter or equal, 0.4914 something, and then divide by 0.0445. T is approximately 11.043 years. Okay? Okay. D, find doubling time. Okay, well, we'll find the doubling time. So here it goes. Maybe you could literally make any number up and just double it, okay? But we've been using 1040 for a deposit, so we'll use 1040 for a deposit, okay? Suppose P is 1040. How long for 1040 to double to 2080? Okay, if you want to do 100, you'd be how long for it to double to 200? If you want to do 1,000, how long for 1,000 to become 2,000? It really doesn't matter what you start with as long as you double it. So this would be my P, this would be my A. Okay, so A equals PE to the RT power because it's continuous. Okay, so how long? So A equals, P equals, R equals, T equals. So A is 2080. P is 1040. R is 0.0445. And T is, I don't know. That's the question. Okay, so I want to know how long for 2080 to become equal to 1040 e to the 0.0445 teeth power. So I propose to switch the sides and divide. So divide this off, and we have E the 0.0445 teeth power equals 2. Okay? It's base e, so we'll use a natural log, which is log base e. All right? So that takes that out of the exponent. We have 0.0445 t equals a natural log of 2. Okay? All I need to do now is divide off that 0.004, or that 0.0445. Might want to put that in parentheses to be on the safe side. And t is approximately, so natural log of 2, hit enter or equal, I'm looking at 0.6931471 blah, blah, blah. Okay, and divide off the 0.0445. Okay, I'm looking at approximately 15.58 years. Okay? Analogously, part E, find the tripling time. Okay? So let's suppose P is 1080. Okay? Or 1040, which is what we've been using. Okay? For our deposit. You can, for the purposes of finding tripling times, doubling times, you can make up any number and double it. That's pretty much all you have to do. So suppose P is 1040. How long for 1040 to triple to 3120? PA. Okay? So, if A equals PE to the RTth power, I want to know, so A equals, P equals, R equals, T equals. So A is 1040. P is, we're starting with 1040. We're tripling it to 3120. Okay. The rate is still 0.0445, and T is we don't know. So when will 3120 equal 1040 e to the 0.0445 times 9th power, times teeth power. Okay, I'm sorry, my brain went back in time. Okay, I'm solving for t, so I will switch the sides and divide. So 1040, because t is my unknown, so I want to move that side to my left. E to the 0.0445 teeth power equals 3120. Divide off the 1040. And I'm left with e to the 0.0445 teeth power equals 3. Okay? Doubling time, you end up with 2. Tripling time, you end up with 3. If you ask for quadrupling time, you end up with 4. Okay? So, that's e to an unknown power. We'll do natural log, which is log base e. Okay? That takes this out, that undoes the exponentiation, and just leaves me the 0.0445t. Okay, and then I'm going to divide off that 0.0045. Sorry, that 0.0445. Okay, I'm going to put it in parentheses and just use a division symbol. Okay, so natural log of 3, hit enter or equal. I'm looking at 1.0986 blah blah blah. Divide by the 0.0445. I'm looking at approximately 24.7 years. Okay. Purple Grove Credit Union offers 4.55% interest compounded monthly. Okay, if 1,040 is deposited now, find balance in 9 years. So it is a non-continuous. That means it's monthly, it's periodic. So this is the appropriate formula. Okay? So A equals, P equals, R equals, N equals, and T equals. So N is 12. It's compounded monthly. Okay? The rate is 0.0455. Time is, in this context, 1,040 is deposited now, find balance in 9 years, and we're starting with 1,040. We don't know what the accumulated value will be in 9 years. That's the question. So A equals 1,040 times 1 plus 0.0455 over 12 to 12 times 9th power. Okay? I strongly recommend you clean this up and never round. Never round. Okay? Never round that. Never round. I'll erase that, but I want to make sure it gets read. Never round. If it doesn't terminate, if it's a repeating decimal, then you keep it as is in parentheses. Okay? That's 108. I'll pretend that that's simply 108. So A equals 1,040. That, and I'm going to see if that divides cleanly. I don't think it does. So 0.0455 divided by 12 plus 1. So what I went ahead and did is I went ahead and took the 0.04, divide first, then add. Okay? And as you can see, there's a bar on top of my 6 that tells me it repeats forever. Okay? So that doesn't divide cleanly. So I'm going to leave it as is. Most problems will not round cleanly, so I recommend you get in the habit of just leaving these in parentheses. Okay, now most calculators, this isn't going to be a problem. You just type in the 1,040 times, open a parenthesis. I'm going to say that again. 1,040 times, open a parenthesis, 1 plus 0.0455 divided by 12. Balance the parenthesis, and then generic exponent button 108. So the nearest cent I got $1,565.09. Okay, unless given reason to assume otherwise, you will round to 2 decimal places to the nearest cent. Okay, so for this one, same formula. Okay, so A equals, P equals, R equals, N equals, and T equals. So accumulated value is going to be 16. So it's compound monthly, so N will be 12 throughout this problem. The rate is 0.0445 or 0.0455. Sorry, my brain was still on the last example, on another example. T is 9. And this 1,600 goes with the future value. We don't know what we're starting with. That's the question. Okay? So I want to know 1,600 equals P times 1 plus 0.0455 divided by 12 to 12 times 9th power. Clean that up, and since p is my unknown, I'm going to switch the sides. Okay, and I hope everything is still visible on screen. It is, good. Okay, so p times 1 plus over 12, that's 108, equals 1600. Okay, so my dream is to divide this off, because I got p times a whole bunch of stuff. So I'm going to divide off that whole bunch of stuff. Okay, so p, that looks more like a D, I'm sorry. P equals the 1600 divided by 1 plus 0.0455 divided by 12 to the 108th power. Okay? If you're using a Casio and most Texas Instruments calculators, this is not a problem. If you're using one of those calculators that doesn't support the order of operations, this is a little dicey. Okay? But for those of you who are using a good calculator, this is not a problem. Just type in the 1600 division, parenthesis. Very important that you include that parenthesis. 1 plus 0.0455 division 12. Balance the parenthesis, your generic exponent button, 108. To the nearest cent, I got $1,063.19, rounded to 2 decimal places. Okay. Okay, so now we're going to talk about a more advanced problem. So how long, or more advanced problems, how long would it take under these conditions for 1,040 to grow to 1,700? Well, it's periodic, compounded monthly. Okay, so A equals, P equals, R equals, N equals, and T equals. So, I want to know how long it will take for, if we start with 1,040, for it to grow into an accumulated value of 1,700. Okay, the rate is 0.0455 as a decimal. It's compounded monthly. What we don't know is the time. That's the mystery. How long would it take? So I want to know how long it will take for 1,700 to equal 1,040 times 1 plus 0.0455 over 12 to 12th power. Okay? T is my unknown, so I'll go ahead and switch the sides. So 1,040, 1 plus 0.0455 over 12 to 12th power equals 1,700. Okay? I like to have my unknowns on the left. Okay, a lot of math people do. Okay, divide off that 1,040, and we have 1 plus 0.0455 over 12 to 12th power equals 85/52. Any fraction capable calculator can tell you that. But where I originally got it from was I divided by 10 to cancel the zeros, and then both those two were divisible by 2. Okay, that's how I did it earlier. Okay, off camera. All right, so we have the logarithm. So what I want to do, sorry, I'm using another method, so I'm going to erase it. Forget I did that. Okay, so I want to get t out of the exponent. All right, so I'm going to use a natural log. divide off the 12 to the 12th power equals a natural log of 85/50. Now, this natural log is log base e. Log base e of something else, of another base, allows me to take this 12t to the front. All right. Now, the next thing I'm going to do is I've got t being multiplied by 12 and by this natural log. So what I propose to do is simply divide them off. Divide off. Okay, so I have t equals the natural log of 85/50 divided by 12 divided by natural log of 1 plus 0.0455 over 12. I will do each of these one at a time. So, natural log, natural log, 85, fraction button or division button, 52nd. Balance the parenthesis, hit enter or equal. I am looking at 0.4914 something. Another option you may be looking at is that's something else you may be seeing. Natural log 85/50. Either way, you should have 0.4914 something. Now, divide by 12, hit enter or equal. Now I'm looking at 0.04095 something. Now divide natural log, parenthesis, very important that you include that parenthesis, 1 plus 0.0455 divided by 12, balance the parenthesis, and we get approximately 10.82 years. All right. Okay, find doubling time. For this, you're just looking for the amount of time it would take for any amount to double. So you could start with 1,000, see how long it takes to get to 2,000. You could start with 100 and see how long it takes to get to 200. You could start with 300 and see how long it takes to get to 600. Okay? We've been using 1,040 for the deposit, so let's just go ahead and keep doing that. Okay? Do. How long, or how about this? Suppose P is 1,040. It's what we've been using for a deposit for several examples, so, or parts of this, so we'll go ahead and use it again. How long for 1,040 to double to 2080? Okay, that's what we want to know. Okay, so this will be our principal, this will be our accumulated value. Okay, so how long for, if the formula is A equals P times 1 plus R over N to the nth power, where A equals, P equals, R equals, N equals, and T equals. We don't know the time, that's the question. It's compound monthly, so 12 times a year, 0.0455. A is 2080, and P is 1,040. So how long for 2080 to equal 1,040 times 1 plus 0.0455 over 12 to 12th power? Okay. Well, this is my unknown, so I'm gonna switch the sides so my unknown is on the left. So 1040 times 1 plus 0.0455 over 12 to the 12th power How long will it take for it to equal 2080? I'm going to go ahead and divide off this 1040. And unsurprisingly, we end up with 2. So 1 plus 0.0455 over 12 to 12th power equals 2. Okay, I want to get the t out of the exponent, so I'll use a natural log. Now, that is a base, that's log base e of a base other than e, so I could take that exponent to the front. So I have 12t natural log of 1 plus 0.0455 over 12 equals a natural log of 2. Okay, so here's what I have going on. T is being multiplied by 12 and this natural log. So I will divide both of those off. Divide off. So the t equals natural log of 2, to be on the safe side, I will put it in parentheses, divided by 12, divided by the natural log of stuff, of a bunch of stuff. Okay, so I'll whip out my calculator. I'll take the natural log of 2 and hit enter or equal. I am looking at 0.693 blah blah blah. Now, with that number still in my calculator, divide by 12 and hit enter or equal. Now I'm looking at 0.5776 blah blah blah. Divide. Natural log, parenthesis. Be very careful to include the parentheses. 1 plus 0.0455 division 12. Balance the parenthesis. Approximately 15.26 years. And that will suffice.